Good morning, good evening, good afternoon, no matter where you're tuning in from. Thank you so much for joining us for this episode of Vector Space Talks. And I'm joined today by
Dat. My name is Dat. Thank you, Terry, for having me. My name is Dat. I work at Arize AI. I'm a solutions architect, kind of by trade. So I work with a lot of companies from big to small, working on things like observability, evals, experimentation. So we'll talk a little bit today about kind of agentic RAG, but we'll get into that in a second. I'll pass it back over to Terry.
Yeah, we're definitely going to be talking about some agentic RAG today, the topic du jour, of course. But before we dive into the presentation, there's a few things I wanted to talk to everyone in the audience today about. So once again, this is Vector Space Talk. We host this every month. If you are here for the first time, you can go to our YouTube and check out our past episodes. And today we're going to be talking about evals with that from Arize. So if you're not familiar, Quadrant just hosted Vector Space Day. We did this at the end of October. It was in Berlin. It was a wonderful time. We had some great talks, including the gentleman joining us today had a great talk on evals. And you can check out all of those videos on the Quadrant YouTube. We've got a nice playlist set up with all of the Vector Space Day talks. You can go in there and catch them all. Good information on how to optimize your search, how to work with agents, memory, all of that good stuff. We're also really excited to announce Quadrant Academy. So this is a hands-on course that takes you from zero to hero on Quadrant. We start off with the very basics of vector search, just how to get everything in Quadrant, how to get a basic search started, and you're going to end up knowing how to scale up your search, how to use advanced techniques like MMR, quantization, all the fun stuff that comes with Quadrant. So if you're interested in learning more about Quadrant, if you're already an expert, but you want to dig even deeper, check out the Quadrant's Essential course. You can see some of the things that we cover there. And of course, we had some courses from some of our great partners. So we've got some courses from DeepSet. We've got a course from Crew AI. We've got a course from Superlinked. So you can go in there and check those courses out as well. Next up, our Discord. So if you're not connected, make sure you jump into our Discord. We've got over 8,000 people that are just talking about search, talking about life, talking about AI all day. If you're looking for a cool place to hang out, meet some new people, and if you're looking for any help with Quadrant, of course, jump in our Discord. You can go ahead and get yourself some information, learn about stuff. And also in our Discord, we host office hours. We're going to be hosting the next office hours November 20th at 11 a.m. Eastern, and I'll actually be hosting that one. So if you like what you see today, make sure you come back to our Discord in a couple weeks, or actually in 8 days, I should say, for that office hours, which is going to be next Thursday, 11 a.m. Eastern. And make sure you check out our Discord. You can come in there, just tell us how your day went, what you're having for lunch, what you're working on with Quadrant. We also have the Quadrant Stars program. So if you're not familiar with the Quadrant Stars, this is our group of space marauders, or I shouldn't say marauders, maybe space explorers that are going out into the field and teaching people about what you can do with Quadrant. So these are people like Rob, who runs Ask News. It's a really cool website where you can basically predict the news. He's put all of the news sources into Quadrant and created the system where you can, through a Discord app or through his own app, ask, hey, what's going to happen to the price of gold in a month? And it'll give you an answer, confidence level with sources cited on why it thinks the price might go up or down. We've also got Pav on there, Clelia, a bunch of cool people. Josh, he's working on some cool stuff as well. So these are all people we're really proud to say are part of the Quadrant community. Love working with these people. And if you're building something cool with Quadrant, if you're really passionate about teaching people about AI, if you want to learn more about Quadrant, check out the Quadrant Stars program. We definitely would love to have more people join us on our rocket ship. Next up, we've got the hackathon and kickoff event. So Quadrant is hosting a hackathon with DeepMind, Google, and FreePick. So you'll be using the Google DeepMind models like Banana Nano and Gemini, and Flash, and you'll be combining it with FreePix all-in-one Creative Studio and Quadrant's vector search engine to build something cool. We've got over $5,000 in prizes. You see that QR code up there on the left. You can go ahead and scan that bad boy, get yourself registered. We're having a kickoff event in San Francisco on the 22nd of November, so in about 10 days. But if you can't make that, don't worry. You can participate virtually from the 22nd to the 14th. It's going to be completely virtual. And of course, we do have a Discord channel for that as well. So if you're looking for more details, you can go ahead and go to sketchandsearch.dev, scan that QR code there, or go on Luma and check out Sketch and Search, and you'll find the hackathon. Really excited for this one, just to see the kind of stuff that people are building now with AI. This is a little teaser for the talk that Dad's giving, but we're getting really past the age of just the chatbot, right? We're going to need some bigger guns to fight this battle. Next up, we've got Quadrant Cloud Inference. So this is one I'm really excited about as a DevRel because I love being able to just build quick demos, spin up some quick prototypes. In the past, you'd have to host your own embeddings or hit a different service, get things out of Quadrant. Now you can do it all in Quadrant. We handle all your inference for you. You can run that natively inside of your Cloud Console. So if you've had the trouble of setting up your own embedding pipeline, I'm sure that's a lot of fun work, but just let Quadrant take care of it for you with this cloud inference. You don't have to worry as you scale about how your system's going to handle it. It's all built into Quadrant. And of course, if you know Quadrant, we're all about speed, and this is no different. So you're going to get your embeddings quickly and be ready to code. So now I'm happy to hand the stage over to Dat for self-improving evaluations for Agentic RAG. Dat, how you doing?
Doing good, Terry. Doing good. Super excited for this. It's going to be really fun. But maybe to kick us off, I will share my screen. Let's see. Let's try this again. Let me share this screen. And then, but really nice to meet everyone here. So my name is Dat. Let's see if we can get that presented. Perfect. So today I want to talk a little bit about, I think the buzzword is like agents, right? How we do search and information retrieval is also going kind of through that as well. So we'll talk a little bit about how these processes kind of run, kind of the big issues we see, and then how are like some of the best teams in the world kind of tackling this. And so my main goal today is just to share some information that I see kind of every day. And so maybe to kick us off, I always ask this fun little question at the beginning of every presentation. Normally I do a poll, but I always ask who thinks building agents is hard. And there's a little joke in San Francisco. Yeah, thanks, Terry. The joke goes, there's two types of people in the world. There's people who think building agents is easy, and there's liars. So,
yep, exactly.
And so I think what we see is that I think building a demo is really easy. But I think building a world-class product, right, which is what I think a lot of us are after, is actually really hard. So what we're finding out from some of our customers, whether you're like a very large company, whether you're from the YC, or you're just a developer just starting on your own, these things are really hard to get right. So when we talk about agents or Agentic RAG, it's not super easy. And so, a little bit about myself. So you're probably like, who is Dat? And how can I even trust this guy who's telling me this stuff? So a little bit about me. From San Francisco, but I recently moved to kind of Europe. I'm a solutions architect by kind of trade. So I work with some of our closest customers at the ground level. So where the rubber meets the road, really working, coding, trying to solve some of our customers' big issues. So I work for Arize. I was also at Dev Day last year with OpenAI. And so I was lucky enough to be in the keynote. And so I do build a lot. So I think I've made the $100 billion or 100 billion token, not dollar, I wish, 100 billion token club, which means, I've built a lot, especially with like, codecs and things like that. And I think, fun fact, I think 100 billion tokens, the commercial value is like, it's like $600,000 is what OpenAI would say, but
it's not too shabby.
Yeah, we built a lot. But I work for Arize, and just by the nature of our business, we are the observability evals experimentation platform, uh, and we get to work across the entire space. So all sectors, all companies of all sizes, open source, enterprise, kind of beyond. And my main goal for today's talk was just to share what I see. I think what we get to see is really unique. We get to see what some of the world's best LLM teams are building. And so what I want this presentation to be is really just educational. And so hopefully you can take something away with you. And so maybe the first thing I'll start off is like, what the bleep is an agent? And so for those who already kind of know, I'm sorry, this is kind of review, but I always really liked Karpathy's take of this. And so like, I stole this directly from Karpathy, so it's not my brain, it's his, but it's always a really good metaphor. So we have different, evolutions of software being like something programming something else. So the way we program. So most people should be familiar, obviously, with code, right? So code explicitly programs your computer. It's an explicit set of steps, directions, from Python to Java to Go to TypeScript, whatever. In the 2010s, right, we started messing around with like XGBoost and deep neural networks, kind of the first stage of them. So in the same way weights of a kind of neural network program the actions of the neural network, that was kind of software 2.0. And then Karpathy goes on to describe software 3.0, which is like, now we're dealing with language. So actually prompts determine what LLMs kind of output or should do, right? And I always thought like this was interesting because I think the core issue is like, how do we find the right balance between these software generations? So building an agent a lot of times is like it's code, it's LLMs, it might be other things like tools as well. So finding the right balance between these software generations is, I think, where a lot of people are at. In our world here in Arize, we can kind of break down what we see in 2025. I think in 2026 we'll have a brand new list, but from what we see is like, these systems are really hard to change. You have to kind of manually go in and change things, whether they're prompts, models, how things are being orchestrated, and they don't kind of self-adapt yet. We'll get into this kind of in a second. When it comes to that balance, like I said, it's either you're planning, too much, where it feels very deterministic and almost like a workflow, and you don't get that kind of magical feeling, or there's kind of not enough determinism, where the solution space is just so big that the complexity is increasing, and it's hard to get things right. When we talk about maybe tool calls or tool guidance, this is like maybe your agent doesn't even have the right set of tools to be able to complete its task, or that we don't do a very good job of guiding which tool we should use and when. Maybe we're a little too ambiguous, right? And there's other things like missing context, or how do we manage state throughout these more longer complex processes? What should we keep and what should we not keep? And so if we distill this down, right, I think I would distill it down to this. The first column is like adaptability and self-learning. These systems actually have a hard time getting better over time automatically without pretty in-depth kind of involvement from a human. And then, like I said, determinism versus non-determinism. I think most people can get this one, and they can understand it. I think context engineering was like, do we have enough context to get the thing done? Turns out one of the hardest things is whatever's in your brain of what you think should happen, getting that into a system or into an LLM so it does the thing that you want, also super tough. And so, I think a lot of the companies like Quadrant have solved most of the like tough parts of information retrieval, which is really nice. And now, when we start to combine these problems with information retrieval for things like Agentic RAG, we're starting to cook, and these are some hard problems. And so, the other thing that we're seeing too in the space is that space is being democratized, unsurprisingly. So it used to be like technical users, right? So think AI eng, data science developers. Now we're starting to see things like product people, business analysts. Everybody wants to help build. And so the other thing we're seeing is that building good product actually involves two types of people. It's technical users and non-technical users. But, and so, I guess the question is, how do you actually build better agents? And so this is what I want to talk about today. How do we actually go and solve these 2025 problems? And if there's anything, I want you to take away from this, it's just this slide. It's a very simple slide, but it really captures the essence of everything. When we talk about the key pieces of making this all work, there's one, observability. And all observability really answers is, what is the thing that I've built actually doing? And there's actually a lot of different layers to observability. And we'll kind of walk through those. Now, you always pair observability with evals, right? And so we'll go into depth of what evals are, but evals help you answer the question of, is the thing that I built actually doing the thing that I want it to, right? So think of it as like signal, what's going well, what's not going well. And everything on the left-hand side is really a means to an end to get to the right-hand side. And this is what most AI teams are after, right? And it's like, how do I make the thing that I have better over time and know I'm making those improvements? And so, we'll kind of walk through that, and maybe I'll do it kind of live, but we'll start with observability. There's many layers to observability. So maybe, for instance, so for some of the more kind of technical people, there's things like traces and spans, which people should be kind of familiar with, which is like, if I have, for instance, a RAG process, right? Not agentic RAG, but maybe regular RAG. Maybe I want to see the question that people are asking, right? Maybe then I want to see, hey, which chunks did we return back, or documents, or in number of things that I returned, right? Maybe we stuff this inside of some sort of like LLM, some prompt template with some variables, and then this goes inside of an LLM. There's an input and an output, kind of great. That might be one layer, but things are getting more complex. And so when we talk about different layers, maybe there's things like the multi-turns. So if a single trace is a single turn, right, that kind of one back and forth of here's a question, here's the return, maybe we want to do things like understand all the turns in a conversation. So we'll talk about how we kind of eval these things, but maybe we want to eval things like, hey, when we did this agentic RAG process, did we fully answer the person's questions, or did they have two questions, or was the user ever frustrated? So you might want to be able to eval across the different turns. Now, when we talk about agents, there's so much more complexity. And maybe an example of that complexity is, maybe we have an agent, right? And we can see a single instantiation of that agent being run, right? So here's an agent, it's maybe running some tools. We might want to look at a visual of that single instantiation. So which path did it end up taking this one time? But what if we wanted to see across every single instantiation, right? And so what we can do here is we can look across the different instantiations. Let me kind of come here and say, hey, what if I mapped out every single time my agent ran, maybe for an agentic RAG process, like what were all the possible routes that it took? And if I took a different route, right, maybe I want to answer a question of what percentage of my traffic went down one path versus another. If I went down a specific path, was there a specific component that caused some amount of latency, for example? If I wanted to look at evals kind of across the different kind of paths, can I understand those evals? Meaning, if I traverse path kind of 1, 2, 3, I notice all my evals are really good, but then I traverse, path, 4, 2, 3, right, for example, and we notice that, oh, our evals kind of suck here. The reason why, the root cause was like, oh, component 4 has a dependency that we never fulfilled, for example. So these kind of views help us understand the agents kind of working at kind of the highest level.
Yeah.
Yeah, and of course, there's like other views that people want to get in terms of observability. There's always things like dashboards and metrics and things like that. So, for example, if people want to just look at a particular, hey, how much does this system cost me over time? If I'm using Quadrant, it's probably very affordable and it works, right? But people might want to look at latency per call, for instance, per message. They might want to look at their evals in real time. But the TLDR of all this is that when we talk about observability, there's many different layers, right? But I'll pause real quick. If anyone in the chat has questions, feel free to. Oh, thanks, Devang. Devang said that agent path is a great way of finding insights from traces. Yeah, it really is. Gleaning insight across the kind of these non-deterministic systems, right? Because now it's no longer like A, B, C. It's like, here's a library of components. The LLM now has the ability to choose, right? And so what this means is your solution space gets so much bigger. The amount of complexity is increasing. So being able to see across the complexity is super helpful. Now, yeah.
I was going to say Devang had another good comment, which is demo is easy, but an actual product takes a lot of iteration. And I think that's where things like Arize come in, where it's like we've all done the toy demo where you don't have any users and people are asking your toy data set questions. But when you go to prod, it's a little bit different, right?
Yeah, completely. And I think for those of on the call who maybe like they work for a product or they work for an enterprise or a company, also the risk tolerance is extremely different for like a demo versus like something that's actually production facing. You might be liable for what your system says or does. You might also have a brand to protect. So 100% Terry, you nailed it.
Mhm.
So I got another fun question. When we talk about evals, the question is like, do evals matter? And so there's this little joke in San Francisco, and it kind of goes like this. There's there's two types of people. There's people who think evals matter, and there's people who are wrong. So a little joke, but for those who kind of are on Twitter, I don't know if you guys saw this conversation 2 months ago. It was really fun to kind of see the AI community come together and really debate this one out. For those who don't know Sean or Swick's Latent Space podcast, amazing podcaster. He's very deep in the space. And Lenny is like the number one like AI PM guy in terms of podcasting, and they both have a very good influence in their communities. But basically, the battle was this. Lenny argues that like evals are really important, and you should really be thinking about them. And Sean was like, hey, one of the best agents in the world has no evals, and maybe you shouldn't use them. It really got the community kind of talking. So what's the right answer here? And to me, I think the answer is it depends. I think they both are right in kind of their own way. When you think about things that have like a very tangible like metric at the end of this, right? So like, did I supply the right answer, right, to my end user, right, when I'm doing agentic RAG? Things like that of like, hey, did I answer the question correctly? Did I do it in terms of the way I want my response to kind of feel, with my company policy? Those are very tangible metrics. And in those use cases, you should almost always have evals, right?
Yeah.
And I think when it comes to something like Claude Code, I think the reason why we don't run evals on generated code, for example, is like, one, it feels like there's many paths to Rome. There's like 101 ways you could write an application. Granted, if you wanted it in a specific like productionized way, you can measure for those things. But I think because when the output of what you're generating can be a little bit more ambiguous and still be correct, you might not need the evals, right? And so in code gen, I personally think you might not need it as much unless there's like some tangible, like I need XYZ unit tests coming out. Still ABC. But the way I think about it is they're kind of both right. And when you're working in a place where you have some sort of measurable outcome, I think evals are an incredibly important thing. And the way most people kind of break this down, and so I'll break this down for folks, is you can think of evals as signal, and they can go into different buckets. And so Devang, good comment. Evals are kind of subjective. I think it depends. Evals are written subjectively, so you subjectively know what you kind of want. And sometimes the LLM will also have some sort of subjective thing. But let me go into what the evals are, and then we can kind of unpack that a little further. So in terms of evals, there's different types. Most people should be familiar with LLM as a judge, but if you're not, LLM as a judge is really simple to understand. You're using an LLM to give you feedback or a label on any process. This can include an LLM process. And so Almost 99.9% of really great LLM teams use this. The reason why is because it scales really well. It does not require a human to get kind of feedback or signal. But humans aren't, outdated yet. They're still very valuable, meaning your end users can also give you feedback, right? Some people call that thumbs up, thumbs down. There's also like response fields, things like that. This is very helpful because it helps you understand, is your end user having a great experience or not? And we'll go into depth later of what happens when your evals are giving you mixed signals. That is actually a signal. There's also things like annotations. So let's say, for instance, Terry here is an expert at, I don't know, finance, or insert some domain here, and we trust Terry's labels. Then Terry will then curate labels, which people call a golden data set. And so it's something that we trust. That's why we kind of call it golden. And now, we'll talk about code and logic-based evals, but the gist behind this one is basically, let's say you have an agent or some part of the agent produce some JSON, right? So go from unstructured to structured. We just want to validate, is this a valid JSON? Or does the JSON have the set of keys that I would expect it to? You don't really need to waste money on an LLM call or have your humans kind of deal with it. You could just validate these evals just with kind of heuristics or code. So you can say, hey, do these 5 keys exist? Yes or no? If no, mark the trace or the span with some sort of marker. And then, of course, we are all building these applications to provide some sort of business metric. We won't go into too much depth here, but just know that if you're building a chatbot to help with customer support, maybe measure, hey, did we actually deflect this user from calling our human support center with the AI support, for example? And so a little pro tip, just for those on the call, some people might ask themselves like, hey, if my LLM as a judge hallucinates once, can't it hallucinate twice? And the answer is absolutely, it can. And so people want to know, how do I quantitatively know that I can trust it? And so what some of the best teams will do is they'll curate a golden data set. So let's say Terry curates an example of 100 things that he's labeled. They will then run their LLM as a judge on that golden data set. So basically, we trust Terry's labels. He represents quality. Now, this column represents scale. And so they'll say, hey, can I tune my LLM as a judge prompt template? Can I get the judge to perform and get the same labels that Terry would otherwise give us? So can I get an LLM to approximate Terry? And then that's how you quantitatively understand if your LLM as a judge can be trusted. You run it on a golden data set, which has labels, and you get labels from it. You can run things like precision, recall, etc. So a little pro tip for those kind of working with these two. When we talk about RAG,
I just want to pause to say, I think that business metrics one is really important, because it doesn't matter how good your other metrics are. If your goal is to build a customer support bot and it's not actually helping with your customer support process, well, metrics be damned, if you will. You got to figure out how, or I should say the dev metrics be damned. You got to get some business metrics in there.
100%. And we'll actually talk about what happens when these signals maybe differ. So as an example, you might have a signal where you're like, your end users are like, I'm not having the best time, but your LLM as a judge is like, hey, everything's smooth sailing. That's when you need to tune your evals and actually improve your evals significantly. So we'll kind of walk through that process.
Yeah.
But maybe for some folks, especially when we're dealing with RAG, or maybe agentic RAG, I think for some people who already do, they use Quadrant and they're trying to understand, is the process need tuning, or do we want to be able to adjust parts of what we're doing? RAG is very simple. It's like maybe someone has a question, we retrieve some context that may or may not have the chunks to answer that. And we want to generate, put these two things together, put it in an LLM and generate it in a helpful way. Each arrow here can represent an example of an eval you could run. Now, an example would be like, hey, if I retrieve some sort of chunk or context, is it relevant to answering the question? Sometimes all of them are. And sometimes you might realize, oh, we're pulling in something else because it's somewhat similar. And so when we think about evals, there's just 3 questions that you should ask yourself and debate is like, what eval do you want to run? Is it LLM as a judge? Do I need to use LLM as a judge or something else? Why do you want to run that eval? So sometimes evals can be a direct measure of something, like the thing you want, but sometimes it's actually a proxy for the thing you actually want. So maybe what you really want is engagement. And maybe the way you do better engagement is like answering questions correctly, right? So really understanding the why of what you're measuring, because you shouldn't measure everything, right? You really want to measure the things that can affect change and good change. And then there's the kind of mechanics of it all. How do we want to run this eval? Is it online? Is it offline? Things like that. And so hopefully that makes sense. But we can also talk about, the complexities of evals. So if we think about some dumb, application, for example, imagine this is some agent. This agent has components, right? So it goes from this to this to this. Maybe it's deterministic. So we know it should go A, B, C. Maybe it's not deterministic. Maybe it's just a library of components and we have some general workflows, but the components can be called, or the tool calls can be called in any order. You can actually eval like very simply, like different components, just like the simple, what came in, what came out of this component. You can zoom out and actually eval the execution branches. So a larger process. Think of it as an agent input and output before it gets past another agent input and output. We want to evaluate agent A, even though there's many pieces running in it. You can do things like evaluate the thing that's routing all of this. If it has a router, for example, you can even evaluate the state machine, which is, think of it as like the multi-turns. So in more complex architectures where you have multiple agents, just know that these things can get complex. So hopefully that makes sense before we kind of dive into evals. But I think we have a question here. Are code evals really giving proper insights? I always think whether a successfully running code really is really prod ready. Sometimes it gives false confidence to a user. Yeah, maybe I'll show you what a code eval is. So let's say I want to run like a code eval. I'll just show you the UI way to do this in our platform, but take the idea rather than kind of how I do it. Let's just say I want to do a code eval. Maybe I want to run it on some traces. Great. I can do things like sample and target specific parts of a trace or span. But TLDR, a code eval might be something like, I want to see if some string that I output contains any other string. So what that looks like in code is something like this, but then you don't have to really run the code. I mean, you don't really have to know how the code works. But basically, you're just saying like, hey, in this output from my LLM, for example, does the output contain words like error, issue, problem? And so the whole idea is that you're using code to give you some sort of signal. And it's like, yes, we are seeing the word error in this output. There's many different types of code evals or heuristics or rules you can set. So does it match a regex pattern? Is it an actual parsable JSON? If you need to get complex, you can, of course, like just write some Python class with some rules or things like that. But to your question, it's, a code eval is really like something that doesn't require an LLM or a human. It's just a heuristic, if that makes sense. So maybe the next question. So you're starting to see like why building agents can be hard. You need observability and evals, and then we can talk about experimentation and those workflows kind of later. But the question is, can we make this process better? So what I wanted to talk a little bit about today is kind of the two virtuous cycles that people are kind of after. So generally, most people know about this left-hand cycle. So what we've been talking about this whole time, which is like, how do I improve the thing that I'm building, right? And it's generally collect some data. Maybe it's telemetry. You want to run some evals on that data so that you can say, hey, what things in my system are breaking, right? And you want to be able to collect those up and then be able to iterate on those things, right? And so in practice, just to show you visually, what that looks like is, collect some data. Maybe it's telemetry, right? So look at all the different traces that are happening. You run some evals. So in Arize, you can run online evals, which are kind of managed for you, or you can run your own. Great. And then find where the evals say something happened, right? So like this label is XYZ. always, look at your evals. Your evals will say like, hey, you hallucinated here. You can run things like the explanation. So the explanation is like, before you give me the label for an eval, tell me why, right? It's like, we hallucinated here because the answer is considered a hallucination because it assumes information not provided in the reference text. We'll talk about why this explainability is really important later, but I can go in and find all the issues that I kind of see, go and collect them up, add them to a data set. And so a data set is just a collection of the things that went wrong. And then you test things on these data sets. I won't go into this workflow super deeply, but you basically take those data sets and you experiment on them. And you say, hey, what is the thing that's going to fix the issue? Is it model changes, prompt changes, the way the agent is configured, the way I'm doing my agentic RAG, things like that. So most people are very familiar with this purple cycle. But what you shouldn't forget is that, the first time you end up running evals, so if evals is signal, right? You'll notice that the way you collect signal is never going to be perfect, whether it's the first time or even through the life cycle of your agent, because honestly, your agent is gaining new functionality over your time. And then also your end users using it are also adapting and changing, right? So meaning the way you collect signal should also change. So if you run evals and you noticed, hey, my users gave me a thumbs down, but the eval said everything is fine. That's a really good indication that you need to improve those evals, right? And it's the same exact process. Find out where your eval said, hey, everything's going well, and they weren't. You can do that by trusting, Terry's annotations or listening to your end users' feedback. Gather those examples where your eval was ran, but not correct. And then you'll want to improve on them. Okay, like, do we need to improve the prompts, be less ambiguous? Do we need to change the type of eval we need to run? Things like that. Do we need to update the signal? So just remember that there's always two cycles that you're after, and each one helps the other. And so in our world in Arize, we ask ourselves questions of, can we automate this process? Because what I just walked you through was pretty manual. Sorry for it being so long. I just wanted to give context. But the question is it possible to automate these two cycles? And in our world, we think it is. So I'm going to introduce something called prompt learning. And so maybe I'll just go into depth kind of here, but prompt learning really tries to solve this issue. It's like, how do we make systems that adapt, that kind of self-heal, right? Where I don't have to explicitly use my human brain and say like, okay, I need to go in and change this prompt because of all these issues. So when we talk about this particular issue, I just want to talk about this. And again, this is not a silver bullet. Prompt learning is not a silver bullet. It needs to be used in conjunction with other things, but we think automation is possible. So for those in the audience, I don't know if you've ever seen this movie. If you have a free weekend, I very much recommend this. This is also from Carpathy, but if you've never seen Memento, the TLDR is like Leonard basically forgets everything every 10 minutes. So what a life that would be. I mean, he's like a goldfish. And so he relies on like fixed decision making, so systems, right? Like, so he has kind of notes and tattoos all over himself to kind of understand like, what do I need to do next, and where am I in the world? As a heads up, Carpathy compares him to LLM without memory. The ability to kind of update himself very easily is really tough, right? If you can only remember 10 minutes and you barely have 10 minutes to kind of update kind of your system prompt, if that makes sense. What I mean by system prompt is system prompts are really important, especially how these things run. You could think of them like as really the context and direction. So for example, Claude, the most successful, one of the most successful agents out there, has a massive system prompt. And so what this means is like, it's just really important for getting things right. And so we released some research recently. I'll actually show the Twitter on this, but this is our kind of research into like, can we automate these system prompt changes? So this is from Aparna. She's our CPO. It did pretty good within the research community. So in the AI community, I got some really good pickup. But the whole idea is kind of this. So I don't know if you guys are familiar with reinforcement learning. So I'll just do a little bit of context, but it kind of goes like this. So RL is basically, you have something, let's call it like a student's brain, and it takes an exam and it gets some sort of, score back. Let's call the exam like the reward function, right? And so it's trying to optimize on this reward function, which is a scalar reward. You as a student might study more, go through more iterations to get smarter. This is generally kind of the algorithm, and it kind of repeats itself until we get to a happy spot. So that's RL, like in a nutshell. I know I oversimplified that, and so what we can do then is, so if you're familiar with something like meta prompting, so meta prompting is, the idea of meta prompting is you take a prompt and you feed it into an LLM to give you a better prompt. So go figure, we take AI, put it inside AI, see if we get better AI. But same exact idea. So it's like, the student takes an exam, you get a score comes out. Instead of me having to like run an algorithm here, gradient descent, whatever, Q-learning, I'm passing this inside of an LLM to produce a better prompt. And so we think this is a good approach, but there's another step you can take. The hardest part about RL is really the scalar reward. It's the math behind it all, right? But what if you can skip this? So in our world, we have prompt learning, which is, imagine you take a prompt, right? And you then take that prompt, pass it into an LLM, but then you also added a data set. So the data set could be some input, some output, some evals that we have, or maybe Terry's annotations, or maybe some of those explanations, right? And then you feed that data set into the LLM with the kind of original prompt. So now we're avoiding the like scalar reward. We're avoiding math, basically. So we're having the LLM kind of, hey, update this prompt given this data set, and then we'll run this kind of all through again, run the evals and see what kind of looks like. And here's the evals again once we run them. So it's the same kind of iteration loop, except we're just skipping this reward function, right? We're just explicitly giving it English. And why we think this is really nice is that like it's so easy time to value, right? Like it's something that you can just do without having to do any math. You're just like, it's just a process. And so you're leaving the optimization up to the LLM. Now, is this a perfect system by any means? No. I think there's smarter ways of doing this. You can combine prompt learning with something like ACE, the ACE framework, because basically you're nuking the prompt every time. Maybe there's parts you want to keep. So I think these two may be in tandem. You can think of it as like renovating a house. Instead of like blowing away the house every time and making it better, you can just renovate the parts that you just want better. So in our world, we have these kind of techniques where we think optimizing these kind of processes can be very much doable. That's a good question. Aman asked, what should be a trigger point to update the prompt? It's a good question. Generally, it's a couple things, and it's also a very loaded question. And so in our world, like, when should you update a prompt? I think if you're noticing that your evals are kind of not doing the thing you want, right? So like if you have evals and you know like some part of the system is broken, maybe we should go update the prompt if we think that would solve it, right? There's some things that the prompt can't solve, right? Which is like the way you do information retrieval, for example. Doesn't matter how much you prompt engineer that, if you're just not getting the context back that you need because you're not using Quadrant or whatever, then changing the prompt won't do that. But generally, prompt changes can affect pretty big changes, and it's low time to value, Aman. So meaning like, if I wanted to change something in my system pretty quickly, generally the prompt is the first place you would look, right? So like, oh, we're being too ambiguous. Well, it's really easy to fix that in a prompt. So I don't know if that's what you meant by your question, but hopefully that answered it. But I think, long story short, this is the problems that we're working on. I hope you guys got some education out of this, and some really nice takeaways of how to maybe improve your own kind of agents or agentic RAG. So I know Quadrant is open source, and so are we. So we have Arize Phoenix here. So you can always just pick up if you want to run things like evals, look at traces, run experiments and things like that. But that's it for my presentation. Thanks so much, Quadrant team, for having me, and then all the great questions. But yeah, I'll pass it back over to Terry.
Yeah, that was awesome. I have a bunch of different questions for you. The first one I want to start off with is, what's the first thing that so let's say I have an agentic system and it's not doing what I want it to, and I'm setting up my eval suite. You can only pick one thing to eval. What are you going for?
Oh, that's such a tough and loaded question. Okay, I hate to be that guy who says like it depends,
Yeah.
but it really does depend, because what I say is like I always coach my teams and the people, my customers, like don't use out of the box evals like as
Hmm.
your final form. If you need to start with them, great, go for it. But the reality of it is like you are building something bespoke. Even the way you do agentic RAG might be bespoke to your business. There's certain things you care about and don't care about. So I wouldn't choose anything out of the box as the final form. Maybe you start with that, but you definitely want to iterate on them, right? Because out of the box evals get you out of the box results almost every time. So tough loaded question there, Terry, but a good one.
Okay, and then one more question, and this is a personal one from me. I'm actually working on a project with agentic vector search for legal tech, right? And I have this data set where there's golden questions that have a yes no answer. So, for example, the question might state, is a landlord able to evict a tenant if they've committed a crime against another tenant? Something like that, right? These questions also have golden passages, though. So you can imagine there's a piece of text that's tied to that yes or no answer. My question is, when I'm doing evals, how do I weigh getting the answer right versus retrieving the right piece of information?
Yeah, it's a good question. So remember, you can run evals for different parts of the process. So there's evals to be like, hey, did I do information retrieval correctly?
Hmm.
Right? Because you could have evals to be like, hey, here's the question, here's the stuff that I returned back from my information retrieval process, agentic RAG, whatever. Run an eval and say like, did I return anything that could even answer that question? If the answer is no, then it's like, okay, let me look at how I'm doing information retrieval. But imagine for a second you're doing information retrieval perfectly fine. And you know that because you're like, oh, this chunk clearly has the golden passage. And what you notice is the response didn't answer it in a way that you would find acceptable. So what
Hmm.
you'll start to find out is like the way I do information retrieval is correct, but the answer isn't. Okay, why is that? Oh, it's because our system prompt actually has conflicting information. It's like, oh, if you're this customer, answer it this way. If you're that. So what you'll find out is like you'll want to run evals to give you signal on the different working pieces in your system. And
Yeah.
everyone's system is different. So if you're doing agentic RAG, you maybe like what parts are agentic RAG and what parts are just interfaces in the application and things like that. But great question.
Yeah. Awesome. I'll go to Stefano. A question. What do you do when multiple agent runs are chained together, like in your original image, where you routed the decision to different workflows?
Yeah, so like maybe multi-agent architectures, Stefano, is where you're going. So like if they're chained together, again, like I said, your evals will get really complex. So let me see where you routed the decision. What to do when multiple. Oh, okay. So maybe your what to do question is like what to do in terms of evals, if that makes sense. But in more complex systems, like you have one agent talking to another, this is where the complexity breaks down, because there's this balance between I run an eval on every single component on every single thing, which costs you money and time and effort. And then there's I don't run any evals, which also costs you money, time, and effort in a different way. So um, the reality of it is the first thing you should do is have a good idea of what your system is doing. So if you can't map out the process, because you'll find out that not all evals are the same. Not all parts of your system are created equally. Maybe things that are routed are very important, because imagine you have a router and you routed somebody the wrong way. Well, every eval subsequently doesn't matter, because like if you like sent somebody down like, hey, this is a chat to purchase e-commerce robot um, agent, and it's like we were supposed to send them to the order form, but we sent them to like an A/B comparison shopping. So if you did an A/B comparison eval on this workflow that we weren't supposed to run, it's kind of a waste. So the reality is a really tough question to answer, and it's kind of what makes this space so fun. Is once you start to get the observability and evals in place, then you have real insight to like, oh, I need to action on this, and then once you action, you have more information. Once you have more information, you can action, and it's just really nice kind of loop.
Yep, you can't rob Peter to pay Paul. back to our good friend Devang. He actually had a two-part question. So in this RL loop that we just saw, do we use a few shot prompt to give example of how an optimum prompt would look like, considering this given data set? And also, is this RL loop dependent on the LLM you're using? Do you think selecting a task fine-tuned model would help improve the output and reduce epochs?
All right, Devang's in the space, man. These are
Yes,
some great
shout out
questions.
Devang.
I love it. So the first question was like, um, do we use few shot to give examples of blah 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 blah? The real cool thing is you can, since it's the prompt optimization task. You can put whatever you want inside of there, right? So maybe it's the ACE framework, and the ACE framework is like the prompt might have structures in it. So like it's like A, B, C, D, E things, right? And A talks about like the tone, B talks about how long the answer should be. So you can keep the structure of this, right? So prompt learning is really about making things better. You can still keep the structure, so they're not independent of each other. If you just did pure prompt learning and say you can blow away the prompt, like rebuild it every time, you probably don't want to do that. So for your first example, you can definitely give few shots of what you like it to be. So it doesn't have to be just pure LLM prescription. You can actually give your human prescription and have the LLM just update the things that you want. So you definitely have a voice in there. You should put that in there if you have some sort of semblance of that. Yeah. And then the second question you asked was also like, is this RL dependent? Is this loop dependent on the LLM model you're using? So the answer would be obviously yes. So the way I think about it is I personally would try to use the best models for creating these prompts, because think about how many more LLM calls will happen with this prompt. So it's almost, you want something like very powerful because it's scaled into everything else you're doing. So do you think selecting a task fine-tune model will improve the output? I've got very strong opinions on fine-tuning. My opinion is that it's very hard to get right, and it takes a lot of effort, time, energy, money to do it. I think fine-tuning models is it's in special cases you would do it, but for most people, if they want the fast time to value, they're just trying to get the thing that they want done in the easiest, fastest possible way. I don't think fine-tuning is really the way in this particular case, but good question.
Keep it simple. Maybe next time we can talk about evaling your fine-tuned model.
Yeah.
And then we got a question from Aman Tandon. Sorry, I missed to add some context. Okay, so the earlier question was, what should be the trigger point to update the prompt? And then a little clarification here. I meant for the prompt learning technique you were explaining. So I want to ask when you want to trigger the LLM to update the prompt.
Yeah, it's a good question. So in terms of automating, like automating the process makes sense, but automating when you should run the process, not super clear yet. I think it really has to do with evals. So I think the prompt learning technique is helpful when you know you need to like optimize a prompt. But maybe your question is like, how do I know when to optimize the prompt? And it's a really tough one, and we haven't solved that one quite yet. It involves looking at your system, because maybe, like I said earlier, optimizing the prompt can't do anything for you because we're not doing the information retrieval correctly. So it doesn't matter how many times you iterate on that prompt, you still won't get the right answer. So maybe the win is a lot harder to answer. I wish I knew that. If we could automate it, I'd be a rich man. But we're still figuring out, and so we're still in the early innings of a very long, AI baseball game. But I don't know that one yet. But when I do find it, Aman, I'll let you know.
Yeah, and I think that's one of the cool things about the AI space is like these techniques are pretty brand spanking new, and we're really at the wild, wild west of what's going on here. So if you have some fun ideas, you can always test them out, and hey, who knows, you might have a novel discovery.
Yeah, be on archive, Aman.
Exactly. So another question that I had personally was just when I'm setting up my evals, can you talk a bit about how you actually digest the information you're getting back from Arize? Are you looking at it with your eyes? Are you looking at some summary statistics? How do you like to play around with the evals?
That's good. Maybe I'll show you. It might be easier to kind of show. So when we talk about like evals, Like imagine we just collected up some data sets of like things that went wrong, right? And all the data set is either traces that get turned into a tabular data set, right? So there might be forms of data, or it could just be some data set of input output pairs. How most people like to run evals is they'll generally run an experiment. And an experiment in this case could be things like, I'll just show you visually what an experiment could be. So imagine you load in like a data set, right? And that contains some data. Maybe we want to run, two different prompts against each other. So let's run this prompt versus some other prompts, right? Great. Maybe we want to change the models that we're using, right? And so I can choose model A versus model B. Great. And generally, most people, as they're iterating, because you don't know if the iteration is the actual fix. So you need to do many iterations or experiments and figure out like, hey, which of these experiments or iterations is the actual fix? So you'll attach evals to these runs. So you'll have a data set, you run it through something brand new models, new prompts, new agent orchestrations, new agentic RAG capabilities, simulations, whatever it is. And most people will just run, to like, hey, this is to help us understand what is our tool call that we should use. And then we'll run the eval to evaluate if the right tool call is being used. Every time you run an experiment, for example, what most people do is they will run these experiments and they'll try to understand, hey, is that last experiment that I ran? So they'll inspect a particular experiment. And the visual way to think about it is this: I ran an experiment and I ran some evals to measure that experiment. How do I compare different, let me choose this one. And like, how do I compare different experiments to each other? If I have 2 or 3 experiments that I've ran, how do I know which one did the best? And what you'll find out is, this is an example of 3 experiments on one eval. If you have multiple evals, you'll see kind of multiple charts here. What you'll find out is like maybe you made a change and you had 5 evals, and that change made 4 of the evals go up, but it made 1 of them drop. You ran another experiment where 3 of them went up and then 2 of them stayed neutral. So now you have these trade-offs, and you have to make the decision as the owner of the system to be like, hey, do I make these trade-offs or these trade-offs? So whether they're like these nice graphical views, some people just want to create custom views of like input A versus input B from experiment 1, 2, 3. So you can actually just curate this. But the reality is there's, a lot of people want to slice the data in many different ways. So as you're running the evals, you might not just use LLM as a judge evals. It might also be, let me come over here. You might want to look at also different types of evals. So it can be as complex as you kind of can imagine it, but it can also be really simple.
Yeah. So in a RAG use case, that might be, let me see what different embedding models give me the best result or the most faithful result or things like that, right?
Yeah, exactly. And there's these trade-offs of like, hey, which, agentic RAG or which quadrant setting, or even trade-offs between cost and accuracy, right? Because some people can afford, I think we all know that LLM applications and models are not 100% accurate, but they're wildly useful. And so you as the owner can make that decision of like, where do I draw the line? For some people, it's, I can accept no risk. For some people, they're like, it's good enough. So it really depends.
Yeah. And now Devang said the dashboard looks very clean and simple. And I agree. I definitely see a kind of a quadrant control center powered by Arize where you can just test out and see, hey, what does changing this embedding model, what does it do to my results, right? Because right now, I think a lot of the way that we do it is based on vibes. We've got some fancy techniques, but at the end of the day, with the evals, especially in information retrieval, oftentimes we want to get the user the result that they want. And sometimes the result that you want isn't the most relevant result. So I love this example from I'm forgetting his name right now, Software Doug, who likes to talk about the red shoes search. So if you search for red shoes and you ask different people what should come up first, everyone has a different answer.
Yeah.
Some people will say, well, red sneakers. Another person will say, well, it should be burgundy dress shoes. Someone else might say it should be red heels.
Yeah.
We just want to get whatever the user is looking for. So how do we go ahead and build that system out?
Yeah. So, and it's so interesting that like, yeah, what's in some people's brains, it's hard for a system to guess that sometimes too.
Like my brother likes to say, computers do exactly what you tell them to do, which sometimes is good, sometimes not so bad. Okay, so final question. Will the slides be made available after the presentation? They certainly shall. We will be sure to share the slides with everyone so you can get that good info. And then I also want to share, please go ahead to quadrant.tech/subscribe. And you can also scan this QR code in the top left. This will keep you updated with everything we've got going on at Quadrant, so you can make sure you stay up to date. And then also, just so you know, it was mentioned earlier, but on the Quadrant YouTube, which is the same place where we'll have all of the Vector Space Day videos, you'll be able to see a recording of this session. So if you joined late or you missed the beginning, or maybe you had to drop off early and you're not hearing me right now, you can always check it out on YouTube. So once again, I just want to say thank you so much to Dat from Arize for joining us today. This was really awesome, Dat. Like I said, I'm using Arize in my evals for my work. So thank you for doing the Lord's work. We appreciate it.
Thanks, Terry. Thanks for having me. Thanks for being my friend and inviting me on here, and for your wonderful audience. And really appreciate you all.
Yes, of course. And we'll go out with a Devang comment. Devang, you've been the MVP. People are ambitious and requirements change constantly. So make sure you stay on top of them with Arize for your evals and Quadrant for your vector search engine. Thank you so much, everyone, for joining us. And we'll see you next time on Vector Space Talks.
Cheers. Bye.